Hello and welcome to PH Maths. Today's explainer is directly proportional, the cleanest relationship in the syllabus. If one doubles, the other doubles. If one triples, the other triples. By the end of this video, you'll know what makes a relationship truly proportional, how to spot it from its graph, and how to find the constant k in 2 seconds flat. Y is directly proportional to x means y equals k times x, where k is a single constant, the same for every pair of values. There's no plus c, no minus c, just y equals kx. Double x and y doubles 2, half x and y halves. The relationship is fixed by one number, k. Find k once and you can predict y for any x. Here's the key insight. The graph of y equals kx is always a straight line through the origin, 0, 0, never just starting anywhere on the y-axis. So to find k, take any pair of x and y values and divide y by x. You'll get the same answer every time. That's because the gradient of k is constant. Same factor in, same factor out. That's what proportional really means. One mistake to watch for, don't confuse direct proportion with y increases as x increases. Any positive gradient does that. Y equals 2x plus 1 increases, but it's not direct proportion because it doesn't pass through the origin. Direct proportion needs the plus c term to equal 0, so always check the line goes through 0, 0. Quick example. Given y equals 12 when x equals 4, find k by dividing. 12 divided by 4 equals 3, so y equals 3x. Now, when x equals 7, y equals 3 times 7, which is 21. 2 lines of working, full marks. Find k, then plug. That's the whole method. Hello and welcome to PH Maths. Today's explainer is inversely proportional, the relationship where one doubles and the other halves. They take turns. By the end of this video, you'll know what makes a relationship truly inverse, how to find k with multiplication instead of division, and why the graph is a curve called a hyperbola. Y is inversely proportional to x means y equals k over x, where k is a single constant. Double x and y halves. Triple x and y becomes 1/3. The product of x and y always stays the same. That fixed product is your k. One constant, one curve, one rule for the whole problem. Here's the key insight. The graph of y equals k over x is a curve called a hyperbola. It approaches both axes but never touches them. To find k, multiply any y by its x. You'll get the same answer every single time. Direct proportion, divide. Inverse proportion, multiply. That's the structural switch. Common slip. Inversely proportional is not just one goes down as the other goes up. Y equals 10 minus x decreases as x increases, but it's not inverse proportion. Inverse proportion needs y times x to be constant. Test it on 2 data pairs. If the products match, you've got inverse proportion. If they don't, you don't. Quick example, 6 workers take 4 days to finish a job. Find k. 6 times 4 equals 24. That's k. So 1 worker takes 24 days. 12 workers take 24 divided by 12, which is 2 days. Notice how more workers means less time. That's inverse proportion working as advertised. Hello and welcome to PH Maths. Today's explainer is compound interest. Interest on interest. The reason millionaires get richer while they sleep. By the end of this video, you'll know the exact formula, why simple interest is linear and compound is exponential, and how to apply it clearly with no second guessing. Compound interest formula. A equals P times 1 plus R over 100, all raised to the power n. P is the starting amount, R is the rate as a percentage, N is the number of years, the bracket is the multiplier. Raise it to the power, then multiply by P. Because each year your interest earns its own interest in the next year. That's the compounding bit. Here's the key insight. Simple interest is linear. You earn the same amount every year. Compound is exponential. Each year you earn slightly more than the last. After 30 years at 7%, you have roughly 8 times your money. Use the multiplier raised to the power. Don't add R% to the original N times. That just gives you simple interest, which is the wrong answer. Classic mistake. Don't add R% to the original N times. That's simple interest. Compound needs the multiplier raised to a power. So if R is 4% over 3 years, you multiply by 1.04 cubed, not by 1.12. A small distinction, but a completely different answer. As a quick example, £500 invested at 4% for 3 years. The multiplier is 1.04. Raise it to the cube, 1.04 cubed equals about 1.1248. Multiply by 500 and you get £562.43. Whereas simple interest would give £560, £2.43 more, coming from compounding. Hello and welcome to PH Maths. Today's explainer is significant figures. And the first thing to know is they are not the same as decimal places. By the end of this video, you'll know what counts as significant, what doesn't, and how to round to any number of sig figs without wobbling. Significant figures are the meaningful digits of a number, starting from the first non-zero digit. That first non-zero digit is your starting point. Everything from there onwards, including any zeros in the middle and at the end, counts. The point is to capture the precision of a measurement, not its size. Here's the key insight. Leading zeros don't count. They're just placeholders telling you the magnitude. So 0.00407 has 3 significant figures. The 4, the 0 in the middle, and the 7. Internal zeros count. Trailing zeros after a decimal point count 2. 6.0 is 2 sig figs, not 1. That trailing zero is significant. Common slip. Rounding 0.00407 to 2 sig figs gives 0.0041, not 0.00. And don't drop trailing significant zeros. 6.0 is 2 sig figs. If you write it as just 6, you've lost a piece of precision. Examiners spot that immediately. Quick example. 23,476 to 3 sig figs is 23,500. Round the 4th digit, keep 3 meaningful digits. 0.05089 to 2 sig figs is 0.051. And 1,234,567 to 1 sig fig is just 1 million. Hello and welcome to PH Maths. Today's explainer is standard form, how scientists write a number with 20 zeros without losing their mind. By the end of this, you'll know what the format actually is, how to convert any number to and from it, and why the front number must always sit between 1 and 10. Standard form means writing a number as a times 10 to the n. A must be between 1 and 10, not equal to 10, but at least 1. N is an integer, positive for big numbers, negative for small ones. The whole point is to capture any number, however big or however tiny, in a tiny, tidy, compact form. Here's the key insight. The value of n is just the number of jumps the decimal point made. A big number is a positive n. A small number is a negative n. So take the number, Slide the decimal point until A sits between 1 and 10 and count your jumps. That's your n. The bigger the number, the more jumps you make, and the bigger n becomes. A common slip, A must be between 1 and 10. So 23 times 10 to the fifth is not standard form. The A value is 23, which is bigger than 10. Slide the decimal one more place. 2.3 times 10 to the sixth. Now you're in standard form. Always check A first. As a quick example, 5,300,000. Slide the decimal 6 places to the left to get 5.3. Answer, 5.3 times 10 to the sixth. Hello and welcome to PH Maths. Today's explainer is surds, roots that don't simplify to nice integers. Root 2, root 3, root 5. They look intimidating, but the rules are surprisingly clean. By the end of this, you'll know how to simplify any surd, how to rationalize a denominator, and the one trap that catches half of students. A surd is a root that gives an irrational answer. Root 2, root 3, root 5, yes. Root 4 equals 2. So no, that's not a surd because the answer is rational. Surds are the leftover roots that won't reduce to a tidy number, and the skill is keeping them in exact form throughout your working, symbolic and never decimalized. Here's the key insight. To simplify a surd like root 50, find the largest square factor. 50 equals 25 times 2, and 25 is a perfect square. So root 50 equals root 25 times root 2, which equals 5 root 2. To rationalize a denominator like 1 over root 3, multiply the top and bottom by root 3. Gives you root 3 over 3. Clean. Classic mistake. Root A plus root B is not equal to root of A plus B. Try it on numbers. Root 4 plus root 9 equals 2 plus 3 equals 5. But root 13 is about 3.6, completely different. You can't combine surds across addition. Multiplication and division, yes. Addition, subtraction, no. Quick example. Root 50 equals root 25 times 2, which is 5 root 2. 1 over root 2, multiply top and bottom by root 2, gives root 2 over 2. And root 5 all squared equals 5. Squaring removes the surd, because squaring undoes the square root. 3 essential moves. Hello and welcome to PH Maths. Today's explainer is the highest common factor, or HCF for short. The biggest number that divides into both. By the end of this video, you'll know exactly how to find the HCF of any pair of numbers using prime factorization. No trial and error, no guessing, and no second guessing. Definition. The highest common factor of two numbers is the largest integer that divides both of them with no remainder. So the highest common factor of 12 and 18 is 6, because 6 divides both, and nothing bigger does. Sometimes called the GCD, or greatest common divisor. Same thing, different name. Here's the method. Prime factorize both numbers, then take only the shared primes at their lowest powers. Multiply these together, and that's your HCF. So if both numbers have a 2 in them, your highest common factor has the lower power of 2. If only one has a 5, the highest common factor has no 5. Shared primes, lowest powers. That's the recipe. Common slip. Don't confuse HCF with LCM. Highest common factor is the highest factor, so it's small, less than or equal to the smaller of the two numbers. Lowest common multiple is the lowest multiple, so it's big, greater than or equal to the bigger of the two. Useful identity. Highest common factor times the lowest common multiple equals the product of the two original numbers. Always. Quick example. Highest common factor of 24 and 36. Well, 24 equals 2 cubed times 3. 36 equals 2 squared times 3 squared. Shared primes, 2 and 3. Lowest powers, 2 squared and 3 to the 1. So the highest common factor equals 4 times 3 equals 12. Done in 3 lines. Hello and welcome to PH Maths. Today's explainer is the lowest common multiple, LCM for short, the smallest number that both numbers divide into. By the end of this, you'll know the prime factorization method that works on any pair of numbers, no matter how awkward. Definition. The lowest common multiple of two numbers is the smallest positive integer divisible by all the given numbers. So the lowest common multiple of 4 and 6 is 12, because 12 divides by both 4 and 6, and nothing smaller does. Sometimes called the lowest common denominator when used as a common denominator. Same idea, different name. Method. Prime factorize both numbers, then take all the primes appearing in either factorization at their highest powers. Multiply those together. That's your lowest common multiple. So if both numbers have 2's, take the higher power of 2. If only one has a 5, the lowest common multiple still includes that 5. All primes, highest powers. That's the rule. Watch out. Don't confuse with highest common factor. Highest common factor is small and a factor. Lowest common multiple is big and a multiple. And here's a fast shortcut for coprime numbers, i.e. numbers with no shared prime factor. For coprime A and B, lowest common multiple equals A times B. So lowest common multiple of 7 and 10 equals 70. Simple. Quick example, the lowest common multiple of 24 and 36. Hello and welcome to PH Maths. Today's explainer is converting recurring decimals to fractions, because every recurring decimal is just a fraction in disguise. By the end of this video, you'll know the multiply then subtract trick that converts any recurring decimal into its exact fractional form. Definition. Let x equal your recurring decimal, multiplied by 10 to the power n, where n is the length of the repeating block. Subtract the original x, and the recurring tail cancels. Solve for x. The result is your fraction. One method applies to every recurring decimal you'll meet. Key insight. The multiplier must match the repeat length. 0.6 recurring, repeat of 1 digit, you multiply by 10. 0.45 recurring, a repeat of 2 digits, you multiply by 100. 0.123 recurring, repeat of 3 digits, multiply by 1,000. The subtraction cancels the infinite tail, leaving a finite number you can divide cleanly. Common slip. Don't approximate. 0.333 recurring is exactly 1/3. Not approximately, not roughly, but exactly. The whole point of this method is to get the exact fraction and not a decimal approximation, and always match the power of 10 to the repeat length. Off by 1 and the method falls apart. Hello and welcome to PH Maths. Today's explainer is the reciprocal. Just flip the fraction. By the end of this, you'll know what a reciprocal really is, why multiplying a number by its reciprocal always gives 1, and the one mistake students make about signs. Definition. The reciprocal of x is 1 over x. The reciprocal of a fraction a over b is b over a. You literally flip it. So the reciprocal of 5 is 1 over 5. The reciprocal of 2/3 is 3/2. The reciprocal of x is 1 over x. Simple, mechanical, never tricky. Key insight. A number multiplied by its reciprocal always equals 1. That's the defining property. 5 times 1 over 5 equals 1. 2/3 times 3/2 equals 1. That's why the reciprocal is sometimes called the multiplicative inverse. It undoes multiplication. Also useful, the reciprocal of a negative number is also negative. Common mistake. Reciprocal is not the same as negative. The reciprocal of 4 is 1/4. That's 0.25, a positive number, not -4. Don't confuse the two. Reciprocal flips, negation changes sign, and these are two different operations. Quick example, reciprocal of 5 is 1 over 5. Reciprocal of 2/3 is 3/2. Flip the top and bottom. Reciprocal of -7 is -1 over 7. Flip and keep the sign. 3 different inputs, same method. Flip and only flip. Hello and welcome to PH Maths. Today's explainer is like terms, the building blocks of simplifying expressions. Same letters with the same powers, their family. You can add family. Different letters or different powers, different families. Don't add. And by the end, you'll spot like terms instantly. Definition: like terms have identical variable parts. 3x squared and 5x squared are like. Same letter, same power. 3x and 3x squared are not like. Same letter, but different powers. And 3x and 3y are not like. They're different letters. The coefficients at the front can differ, but the letters and powers must match exactly. Key insight: you can only add or subtract like terms. So 2x plus 3x equals 5x, yes? 2x plus 3x squared stays as it is, because those are different families and you can't combine them. The same rule applies in more complex expressions. Split into the family groups first, and then combine within each group. Common mistake: 2x plus 3 is not 5x. The 3 is a constant. It's not in the x family. The constant family has its own column, and x and 2x are like, but x and x squared are not. Different powers, different families, always. Hello and welcome to PH Maths. Today's explainer is expanding brackets, multiplying everything outside the bracket by everything inside. By the end of this video, you'll know the single bracket rule, the double bracket FOIL method, and the sign trap that catches half of candidates. Definition: expanding brackets means removing them by distributing the multiplication. Single bracket, A times the quantity B plus C equals AB plus AC. Multiply the outside by each thing inside. That's it. The pattern scales up. Same rule applies whether the multiplier is a number, a letter, or another bracket. Key insight: for double brackets, use FOIL. First outer, inner, last. Multiply the first terms of each bracket, then the outer two, then the inner two, then the last two. Add them up. For triple brackets, expand 2 of them first, then multiply the result by the third, one step at a time. Watch out for sign errors. X minus 2 times x minus 3 is x squared minus 5x plus 6, not x squared plus 6. The two minus signs multiply to a plus 6 at the end. And don't forget the middle term in x plus a, all squared. It's x squared plus 2a, x plus a squared, not just x squared plus a squared. Quick example, 2x plus 1 times x minus 4. First, 2x times x equals 2x squared. And then the outer, 2x times minus 4 equals minus 8x. The inner, 1 times x equals x. And last, 1 times minus 4 equals minus 4. Add 2x squared minus 7x minus 4. Hello and welcome to PH Maths. Today's explainer is factorising, the reverse of expanding. You're putting the brackets back. By the end of this video, you'll know the common factor method, the quadratic trinomial method, and the one habit that catches every mistake before it costs you a mark. Definition. Factorising means rewriting an expression as a product of factors. So 6x plus 9 factorises to 3 times the quantity 2x plus 3 by extracting the common factor of 3. And x squared plus 5x plus 6 factorises to x plus 2 times x plus 3. That's the quadratic case. Key insight. Always check your answer by re-expanding. If the result doesn't match the original, you've factored wrong. Start by pulling out the highest common factor first, then for a quadratic of the form x squared plus bx plus c, find two numbers that multiply to c and add to b. Those two numbers go inside the brackets. Common mistake. Forgetting common factors. 6x squared plus 12x factorises to 6x times the quantity x plus 2. Both the 6 and the x come out. Not 6 times x squared plus 2x. Pull out all the common factors, not just one. Quick example, x squared plus 5x plus 6. Find two numbers that multiply to 6 and add to 5. That's 2 and 3. So the factorisation is x plus 2 times x plus 3. Re-expand to check. Gives x squared plus 5x plus 6, which is a match. So you are done. Hello and welcome to PH Maths. Today's explainer is rearranging to change the subject of a formula, getting the letter you want all alone on one side. By the end of this, you'll know the standard work outwards method and the one tricky case where you have to factorise. Definition. Changing the subject means rearranging a formula so that one specific variable is isolated on one side. So if you start with y equals 3x plus 5, and you want x as the subject, you'd rearrange to get x equals y minus 5, all over 3. Same equation, different layout. Method. Do the same thing to both sides and work outwards. Undo plus and minus first, then times and divide, then powers and roots last. Reverse order of operations. Strip off the outer layers before you get to the inner ones. And if the target letter appears twice, get them both on the same side and factorise out. Common mistake. When the target variable appears twice, you must factorise. Don't ignore one of them and hope it goes away. Collect both copies of the variable on one side, then factor them out as a common factor. Now you can divide and isolate cleanly. Quick example. Make x the subject of y equals 3x plus 5. So subtract 5 from both sides, so y minus 5 equals 3x, and divide both sides by 3. X equals y minus 5, all over 3. Two operations, both sides, every time, done. Hi, welcome to PH Maths. Today we're talking about the quadratic formula, the tool that solves any quadratic equation. It's usually given in the exam, but if you don't learn it and spend some time thinking about it, you won't know how to use it. And using it isn't actually that hard, but there are a few pitfalls and common mistakes people make. I'd highly recommend memorizing it and then take it slowly, writing it down in stages as you go. By the end of this, you'll know the formula, the sign of B-trap, and exactly when no real solutions exist. So let's have a look at it. So for any quadratic in the form ax squared plus bx plus c equals 0, x is equal to minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. That's the formula. Identify a, b and c, plug them in and simplify. And remember, it is 2a on the bottom, not a single a. And the plus or minus gives you two solutions in one expression. If you get a negative number inside your square root, do go back and check your working. Some quadratics do have a negative value in the square root, but they won't come up in the exam. Key insight: the plus or minus produces two answers, one with plus, one with minus. If the discriminant, that's the b squared minus 4ac, is positive, you get two real solutions. If it's 0, you get one repeated. If it's negative, there are no real solutions exist. Always check the sign of b. It's the easiest place to make a mistake. Common mistake: sign of b. For x squared minus 3x plus 2, b equals minus 3. So minus b equals plus 3. Get that sign right and the rest will follow. And the 2a in the denominator divides the entire numerator, both the minus b and the square root, not just one of them. And as mentioned earlier, remember it's 2a, not a single a. Quick example: solve x squared plus 5x plus 6 equals 0. So a equals 1, b equals 5, c equals 6. Plug in x equals minus 5 plus or minus root of 25 minus 24, all over 2. That's minus 5 plus or minus 1 over 2. So x equals minus 2 or minus 3. Done. Hello and welcome to PH Maths. Today's explainer is completing the square, the move that turns any quadratic into a perfect square plus a leftover. By the end of this, you'll know the halve it, square it, subtract trick, and how to read the turning point of a quadratic straight off the completed square form. Definition: completing the square means rewriting x squared plus bx plus c in the form x plus p all squared plus q. The point of doing this is twofold. It makes the quadratic easier to solve, and it also gives you the turning point of the parabola directly, with no calculus needed. Method: for x squared plus bx, the trick is to halve b, square the result, and subtract. So x squared plus 6x becomes x plus 3 all squared minus 9. The plus 3 comes from halving the b. The minus 9 comes from squaring that plus 3. Then add whatever constant c was in the original. 3 steps, always. Common slip: forgetting the minus b over 2 squared term. The bracket on its own would overshoot. It adds an extra constant that wasn't in the original, so you subtract that constant back out. Halve it, square it, subtract, and only then add the c. Hello and welcome to PH Maths. Today's explainer is the discriminant, the part under the square root in the quadratic formula. It tells you how many solutions a quadratic has before you do any solving. By the end of this video, you'll know the 3 cases and how to apply them in seconds. Definition: the discriminant, written with the Greek letter delta, equals b squared minus 4ac. It's the expression that sits under the square root in the quadratic formula. The sign of the discriminant tells you how many real solutions the equation has, without you needing to actually solve it. 3 cases. If the delta is positive, you have 2 real solutions. The parabola crosses the x-axis at 2 points. If delta equals 0, you have 1 repeated solution. The parabola just touches the x-axis. If delta is negative, no real solutions exist. The parabola never reaches the x-axis. Memorize these 3 outcomes. Common mistake: sign of b. b equals minus 3 still gives b squared equals plus 9. Squaring always produces a positive, so when b is negative, b squared is positive. That's not a sign error, that's just how squaring works. Get b squared right and the rest follows. Quick example: x squared minus 4x plus 3 equals 0. So a equals 1, b equals minus 4, c equals 3. The discriminant equals 16 minus 12 equals 4. 4 is positive, so 2 real solutions exist. Confirmed without solving. 2 marks in 20 seconds. Hello and welcome to PH Maths. Today's explainer is the difference of two squares, the factorisation pattern that you should spot instantly. By the end of this, you'll know the signature, the rule, and exactly when it does and doesn't apply. Definition: a squared minus b squared factorises to a minus b times a plus b. That's the entire rule. Two squared terms subtracted become two brackets, one with minus, one with plus, same two letters in each. Symbol pattern that, once you've memorized it, you will see everywhere. Key insight: 3 signals tell you it's the difference of two squares. Two terms only, both perfect squares, and they're separated by a minus. All 3 must be true. It only works for minus, never for a plus. And both terms must be perfect squared. X squared, 4x squared, 25, but not 3x squared or 7. Common mistake: trying to apply the rule to a squared plus b squared. That doesn't factorise over real numbers. Different operation, different result. So a squared minus b squared, yes, factorise. A squared plus b squared, leave alone. Quick example: a squared minus 25 factorises to x minus 5 times x plus 5. Hello and welcome to PH Maths. Today's explainer is the algebraic identity, an equation that holds for every value of the variable, not just specific ones. By the end of this video, you'll know the difference between an identity and an equation and how to prove or use them. Definition: an algebraic identity is a relationship that's true for all values of the variable, written with 3 lines, the equivalent symbol, instead of 2 lines for equals. So x plus 1 all squared is identically equal to x squared plus 2x plus 1 for any x at all. Key insight: to prove an identity, expand both sides and show they match. Every term, every coefficient. To find unknowns inside an identity, substitute specific values of x that simplify the equation. Pick x equals 0, x equals 1, or whichever makes the algebra drop out. Smart choices save calculations. Common confusion: equation versus identity. An equation is true for specific values of x, like x squared equals 4, which is true for x equals plus or minus 2. An identity is true for all values, every single one. Different concept, different symbol. Don't treat one as the other. Quick example: prove that x plus 1 all squared is identically equal to x squared plus 2x plus 1. Hello, welcome to PH Maths. Today's explainer is algebraic fractions. Same rules as number fractions, just with letters in them. By the end of this, you'll know how to add them, multiply them, and cancel them down. And the one rule that catches every careless student. Definition: an algebraic fraction is a fraction with variables in the numerator or denominator or both. So x over 3, or x plus 1 over x minus 2. The rules of arithmetic still apply. Adding needs a common denominator, multiplying combines numerators and denominators, and cancelling only works on shared factors. Key insight: to add or subtract, find a common denominator first. To multiply, combine across, top times top, bottom times bottom. And to simplify, factorise both the numerator and the denominator. then cancel any shared factor. Always factorise first, because most cancellation only becomes visible after factorising. The critical rule: you cancel factors, not terms. So x plus 3 over x plus 5 does not simplify to 3 over 5. The x's aren't multiplied, they're added. Only multiplicative factors cancel. The same rule that stops you from cancelling individual terms inside a sum. Quick example: simplify x squared minus 9 over x squared plus 5x plus 6. Well, factorise the top, x minus 3 times x plus 3, and then factorise the bottom, x plus 2 times x plus 3. The x plus 3 cancels, so the answer, x minus 3 over x plus 2. Hello and welcome to PH Maths. Today's explainer is similar shapes. Same shape, different size. By the end of this, you'll know the scale factor rule for lengths, areas and volumes, and you'll never confuse linear with square or cubic ratios again. Definition: two shapes are similar if one is a scaled version of the other. Same angles, sides in the same ratio. If you scale all the lengths of a triangle by a factor of 2, you get a similar triangle. The shape stays the same. The size doesn't. Key insight: the scale factor k is for lengths. Areas scale by k squared. Volumes scale by k cubed. So if the lengths double, the areas quadruple, and the volumes go up by a factor of 8. Identify k first, the linear ratio, then square it for areas and cube it for volumes. Common mistake: forgetting to square the scale factor for area or cube it for volume. If the question asks for area or volume in similar shapes, the linear scale factor alone is wrong. Square or cube as needed. Quick example: two similar cones with radii in the ratio 2 to 3. So the linear scale factor, 2 over 3. The volume scale factor, 2 cubed over 3 cubed, equals 8 over 27. So if the small cone has a volume of 16, the large cone has a volume of 16 times 27 over 8, which equals 54. Right, if any of this is going to stick beyond this video, drop into phmaths.com. You'll find a free 4-week GCSE higher revision planner ready to download, plus the mastery workbooks, one for every higher topic, every answer fully worked, every common slip fagged. Hello and welcome to PH Maths. Today's explainer is congruent triangles. Same shape, same size. Not similar, identical. By the end of this video, you'll know the 4 ways to prove two triangles are congruent and the one case that looks like it should work but doesn't. Definition: two triangles are congruent if they're identical in every measurement, every side and every angle. Same shape, same size. They might be rotated or reflected, but the dimensions match perfectly. Different from similar. Similar is same shape only, different sizes. Key insight: 4 congruence tests, each abbreviated by initials. SSS, 3 sides match. SAS, 2 sides and the included angle. ASA, 2 angles and the included side. RHS, right angle, hypotenuse and one other side. Cite the test by name in your proof. That's where the method mark lives. Watch out. ASS doesn't work. 2 sides and a non-included angle is ambiguous because you can usually construct 2 different triangles that fit. So that's not a valid congruence test. Stick to the 4 named tests and you're safe. Quick example, 2 triangles, both with sides of lengths 5, 7 and 9. All 3 sides match. That's SSS. Therefore, the 2 triangles are congruent. 2-line proof, 2 marks. Always name the test you used. Hello and welcome to PH Maths. Today's explainer is Pythagoras' theorem. Give me 2 sides of a right triangle and I'll find the third. By the end of this video, you'll know the formula, the trick to identifying the hypotenuse first, and the 4 Pythagorean triples that show up over and over again. Definition. In any right-angled triangle, a squared plus b squared equals c squared, where c is the hypotenuse, the longest side, and always opposite the right angle. The legs are a and b, the 2 shorter sides that meet at the right angle. Square both, add them, and take the square root for the hypotenuse. Key insight: identify the hypotenuse first. It's the longest side opposite the right angle. Once you know which side that is, you can write your equation correctly. If you're solving for one of the shorter sides, rearrange. C squared minus b squared equals a squared. And memorize the famous triples 3, 4, 5, 5, 12, 13, 8, 15, 17, and 7, 24, 25. Common mistake: putting the hypotenuse on the wrong side of the equation. The hypotenuse squared is the bigger side of the equation, always equal to the sum of the other 2 squared. If you put it on the wrong side, you'll get a negative under the square root. Quick example, legs of 3 and 4, hypotenuse squared equals 9 plus 16, which equals 25. Hypotenuse equals 5. The classic 3, 4, 5 right triangle. Once you've spotted that, no calculators needed, an instant answer for you. Hello and welcome to PH Maths. Today's explainer is bearings. Clockwise from north, 3 digits, always. By the end of this video, you'll know the format, the 2-direction rule, and the parallel line trick that solves every bearings problem on the syllabus. Definition. A bearing is a direction measured clockwise from north and written as 3 digits. So a bearing of 070 degrees means 70 degrees clockwise from north. Always 3 digits, even if the actual angle is single or double. Bearings range from 000 up to 359. Key insight. Always mark north at every point in your diagram. At the start, at the end, anywhere a bearing is given or asked for. The bearing from A to B and the bearing from B to A differ by exactly 180 degrees. Use parallel north lines and co-interior angles to chase the bearing across the diagram. Common slip. Writing 57 degrees instead of 057. Bearings need 3 digits, regardless of magnitude. So 57 becomes 057. 9 becomes 009. Always pad with leading zeros. That's the convention. Quick example. B is on a bearing of 070 from A. What is the bearing of A from B? Well, add 180. 070 plus 180 equals 250. Done. Every bearings problem is really an angle chase, with the parallel north lines doing the heavy lifting. Hello and welcome to PH Maths. Today's explainer is the angle in a semicircle, one of the cleanest circle theorems on the syllabus. Diameter plus any point on the circle equals a right angle. By the end, you'll spot this every single time and pocket the easy marks. Definition. If A and B are the two endpoints of a diameter and P is any other point on the circle, then the angle APB is a right angle, 90 degrees every single time. No exceptions, no special cases. Every triangle drawn from a diameter to a point on the circle has a right angle at that point. Key insight. Spot a diameter. You've unlocked a right angle. Once you've got the right angle, you can use either Pythagoras or SOHCAHTOA to find any other side or angle. This theorem is 2 free marks on a Circle Theorems paper. Recognize the configuration and the rest of the question opens up. Common slip. Both endpoints must be on the circle. A line that passes through the center but doesn't reach the edge isn't a diameter. And the angle has to be at a point on the circle. Not inside, not outside. All 3 points on the circle, with 2 of them forming a diameter. Quick example. Diameter AB equals 10. P is on the circle. AP equals 6. Find BP. Right angle at P from the semicircle rule. Pythagoras. AP squared plus PP squared equals AB squared. 36 plus BP squared equals 100. BP squared equals 64. BP equals 8. Hello and welcome to PH Maths. Today's explainer is the Cyclic Quadrilateral, a 4-sided shape with all 4 vertices sitting on a circle. By the end of this, you'll know the opposite angles sum to 180 rule and exactly when to apply it. Definition. A cyclic quadrilateral is a 4-sided polygon with all 4 vertices lying on the circumference of a circle. The vertices are sometimes called concyclic. The key property, opposite vertices have angles that sum to 180 degrees. Key insight, the opposite angles add to 180. Top vertex plus bottom vertex equals 180. Left vertex plus right vertex equals 180. 2 opposite pairs, 2 180 sums. The adjacent angles are not related by this rule, only the opposite ones. Common mistake, don't apply the 180 degree rule to adjacent angles. Those are angles next to each other in the polygon, not across from each other. The rule only works for vertices directly opposite. Mark them on your diagram before applying. Quick example, a cyclic quadrilateral ABCD, angle A equals 80 degrees, angle C, which is opposite A, equals 100, because 80 plus 100 is 180. And the other pair, angle B plus angle D, equals 180. So if angle B equals 70, angle D equals 110. Hello and welcome to PH Maths. Today's explainer is the alternate segment theorem, the circle theorem that catches students out more than any other. By the end, you'll know exactly when to use it and how to spot the alternate segment without second guessing. Definition. When a tangent meets a chord at a point on the circle, the angle between the tangent and the chord equals the inscribed angle in the opposite segment of the circle. The chord divides the circle into 2 segments. The angle on the far side of the chord matches the tangent chord angle. Key insight. Use this theorem when nothing else fits. Spot a tangent, a chord, and a 3rd point on the circle on the opposite side of the chord from the tangent. The tangent chord angle equals the inscribed angle at that 3rd point. It's the theorem that rescues a circle problem when everything else is stuck. Watch out. Pick the angle on the opposite side of the chord, not the same side. The alternate in the theorem name refers to the opposite segment. If you pick the same side, you've got the wrong angle. Always identify the chord first, then go to the far side of it. Quick example. Tangent T meets chord AB at point A. Angle TAB equals 40 degrees. C is on the major arc, the side of AB opposite the tangent. Then angle ACB equals 40 degrees too, by the alternate segment theorem. 3-line proof, 2 marks. Hello and welcome to PH Maths. Today's explainer is arc length and sector area. A sector is a pizza slice and the fraction is what matters. By the end of this, you'll know both formula, the single structural pattern they share, and the easy mistake that confuses one with the other. Definition. Arc length equals theta over 360 times 2 pi r. Sector area equals theta over 360 times pi r squared. Theta is the central angle of the sector in degrees. R is the radius. Two formulae, same structure, a fraction of the whole circle. Key insight, both formulae start with the same fraction, theta over 360. That fraction is what slice of the full circle your sector takes up. Once you've got the fraction, multiply by the circumference for the arc length or by the area for the sector area. Same fraction, two uses. Common slip, don't confuse arc with sector. The arc is the curved edge of the slice, just the length. The sector is the area of the slice, the filled-in region. One is a curved length, the other is a two-dimensional area. Different units, different answer. As a quick example, radius 6, sector angle 60 degrees. Arc length equals 60 over 360 times 12 pi. That's 1/6 of 12 pi, which is 2 pi. Sector area equals 60 over 360 times 36 pi. That's 1/6 of 36 pi, which is 6 pi. Hello and welcome to PH Maths. Today's explainer is SOHCAHTOA, the mnemonic that single-handedly carries the right-angled trigonometry section of your paper. 3 ratios, 3 letters each, all built from the sides of a right-angled triangle. By the end of this, you'll know what each letter stands for, when to use which ratio, and the one common mistake. SOHCAHTOA stands for 3 ratios, so sine of the angle equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and TOA, tangent equals opposite over adjacent. The hypotenuse is the longest side, opposite the right angle. The opposite is across from your angle. The adjacent is the leftover. 3 sides, 3 ratios. Here's the bit that actually matters. Memorizing SOHCAHTOA isn't the hard part. The skill is spotting which ratio to use. So label your triangle. Hypotenuse first, the longest side, opposite the right angle. Then opposite, which is the one across from your angle. Then adjacent, the leftover. Check which 2 sides the question mentions and the ratio picks itself. One mistake every year, SOHCAHTOA only works inside a right-angled triangle. If there's no right angle, there's no SOHCAHTOA. You need the sine rule or the cosine rule instead. And one bonus warning, the labels opposite and adjacent depend on which angle you've picked. So choose your angle first and then label. As a quick example, right-angled triangle, angle 30 degrees, hypotenuse 10 centimeters. Find the opposite. Opposite and hypotenuse, so that's so sine. Sine of 30 equals opposite over 10. Sine of 30 is 1/2, so opposite over 10 equals 1/2, meaning opposite is 5 centimeters. Done. Hello and welcome to PH Maths. Today's explainer is the sine rule, your tool for any triangle, not just right-angled ones. By the end of this, you'll know the formula, when to reach for it, and the one case where you should not use it. Definition. For any triangle with sides A, B, and C, opposite angles A, B, and C, A over sine A equals B over sine B equals C over sine C. All three ratios equal each other. Pick any two of these equalities to solve any unknown side or angle. Same triangle, three equivalent equations. Key insight: use the sine rule when you have an angle and its opposite side, plus one more piece of information. Two angles and one side, sine rule. Two sides and one non-included angle, sine rule. The pattern: wherever a known angle and its opposite side appear together, sine rule is your tool. Watch out, don't use the sine rule for SAS, two sides and the included angle. That's cosine territory. Sine rule fails when you don't have an angle-side opposite pair. You can't form the first equality without one. Wrong tool, wrong answer. Quick example: triangle with angle A equals 40 degrees, angle B equals 75 degrees, side A equals 8. Find B. Set up: B over sine 75 equals 8 over sine 40. Rearrange it: B equals 8 times sine 75, all over sine 40. On a calculator, that's about 12.02. Hello and welcome to PH Maths. Today's explainer is the cosine rule, the second tool for any triangle, used when the sine rule won't fit. By the end of this video, you'll know both versions, the side formula and the angle formula, and exactly when to reach for each. Definition: for any triangle with sides A, B and C, opposite angles A, B and C, the side formula is A squared equals B squared plus C squared minus 2BC cosine A. The angle formula is cosine A equals B squared plus C squared minus A squared all over 2BC. Two faces of the same rule. Key insight: use the cosine rule when you have SAS, i.e. two sides and the included angle, or SSS, three sides. The side formula gives you the missing third side when you have SAS. The angle formula gives you a missing angle when you have SSS. Different inputs, different version. Common mistake: mixing the side formula and the angle formula up. The side formula starts with A squared. The angle formula starts with cosine A. If you find yourself dividing the wrong way, you've used the wrong version. Write both down on your paper at the start of the question and pick. Quick example: a triangle with sides 5 and 7 included angle 60 degrees. Find the third side. So use the side formula. Third side squared equals 25 plus 49 minus 2 times 5 times 7 times cosine 60. That's 64 minus 35 equals 39. So the third side equals root 39, which is roughly 6.24. Hello and welcome to PH Maths. Today's explainer is the exact trig values, sine, cosine and tangent of 30, 45 and 60 degrees. They come up every paper, every year on the non-calculator section. Memorize them once and you'll never lose those marks again. Definition: exact trig values are the sine, cosine and tangent of 30, 45 and 60 degrees, expressed as surds or fractions, not decimals. The point of exact form is that these values appear without a calculator on the non-calculator paper, and you're expected to know them instantly. Memorize these. Sine of 30 is 1/2. Sine of 45 is root 2 over 2. Sine of 60 is root 3 over 2. Cosine goes the other way. Cosine of 30 equals root 3 over 2. Cosine of 45 equals root 2 over 2. Cosine of 60 equals 1/2. Tangent of 30 is 1 over root 3. Tangent of 45 is 1. Tangent of 60 is root 3. Common mistake, mixing sine 60 with cosine 60. Sine grows from 0 up to 1 as the angle increases from 0 to 90. Cosine shrinks from 1 down to 0, so sine 60 is root 3 over 2, which is close to 1. Cosine 60 is 1/2, which is smaller. Sine is growing, cosine is shrinking. Lock that thinking in. As a quick example, find sine 60 times cosine 30. Well, sine 60 equals root 3 over 2. Cosine 30 also equals root 3 over 2. So multiply root 3 over 2 times root 3 over 2, which equals 3 over 4. No calculator needed. 3/4, exact answer. Hello and welcome to PH Maths. Today's explainer is the three averages: mean, median and mode. They answer different questions, give different answers, and choosing the right one is half the mark. By the end of this, you'll know which to use when. Definitions. Mean. Add all the values and divide by how many there are. Median. The middle value when the data is ordered. Mode. The most common value, the one that appears most often. Three different ways of saying a typical value, and they don't always agree. Key insight. Mean is sensitive to outliers. One huge value can drag the whole average up or down. Median is robust to outliers. It stays put even when the extremes appear. Whereas mode is most useful for categorical data. Favorite color, most sold shoe size. Pick the average that matches the kind of data and the kind of question. Common slip, forgetting to order the data before taking the median. The median is the middle value of an ordered list. So write the data out, smallest to biggest first, then find the middle. Without ordering, you'll get the middle of the original list, which isn't what the median is. Quick example, so the data 1, 2, 2, 3, 100. For the mean, you add and divide. So 1 plus 2 plus 2 plus 3 plus 100 equals 108. Divided by 5 gives 21.6. The median is the middle value when they're ordered, so 2. Mode, also 2, is the most common. Median and mode feel more representative when there's a giant outlier. Hello and welcome to PH Maths. Today's explainer is cumulative frequency, a running total of how many data points sit at or below each value. By the end of this video, you'll know how to build the table, plot the graph, and read off medians and quartiles. Definition. The cumulative frequency at any class boundary is the running total of all the frequencies up to and including that boundary. So if the first class has a frequency of 5 and the second has a frequency of 8, the cumulative frequency at the end of the second class is 13. Adds up class by class. Key insight. The graph is S-shaped. It starts shallow, steepens through the middle, then flattens off at the top. To find the median, draw a horizontal line at 50% of the total frequency and read off the x value. For Q1, use 25%. For Q3, use 75%. Quartiles drop out instantly. A common mistake, plotting at the midpoint of each class. Cumulative frequency should be plotted at the upper class boundary, because that's the highest value the running total includes by that point. Midpoint plotting gives a shifted graph and the wrong median. Quick example. 80 students in total. To find the median, locate the 40th student on the y-axis and read across to the curve, then down to the x-axis. That x value is the median. Q1 is at the 20th student. Q3 is at the 60th. Read off, write down, 3 marks each. Hello and welcome to PH Maths. Today's explainer is the interquartile range and box plots. The interquartile range is the spread of the middle 50% of your data, the one measure of spread that ignores outliers. By the end of this video, you'll know how to calculate it and read a box plot fluently. Definition: the interquartile range, or IQR, equals Q3 minus Q1. Q1 is the lower quartile, 25% of the way through your ordered data. Q3 is the upper quartile, 75% of the way. The interquartile range captures the middle half of the data. Key insight: the interquartile range is less affected by extremes than the range, because it ignores the top and bottom 25%. A box plot shows 5 summary statistics: the minimum, Q1, the median, Q3, and the maximum. The box is from Q1 to Q3. That's the interquartile range represented graphically. 2 short whiskers extend out to the minimum and max. Common confusion: range versus interquartile range. Range is the max minus the min, easily skewed by a single outlier. Interquartile range is Q3 minus Q1, robust to outliers. So if your data is mostly tidy with one wild value, the range might be 100, while the interquartile range is just 16. Quick example: Q1 equals 12, Q3 equals 28. The interquartile range equals 28 minus 12, which equals 16. Even if there's an outlier at 100, the interquartile range stays at 16. The range would balloon, but the interquartile range holds firm, and that's why examiners ask for it. Hello and welcome to PH Maths. Today's explainer is histograms with frequency density. When class widths are unequal, the height of the bar can't just be the frequency. You need frequency density. By the end of this video, you'll know how to calculate it and read areas off the chart. Definition: frequency density equals frequency divided by class width. So a class with frequency 20 and width 5 has density of 4. A class with frequency 20 but width 10 has density 2. Same frequency, different density, because the area, not the height, has to represent the frequency. Key insight: the area of each bar, height times width, represents the frequency. Height alone would be misleading when widths differ. So if your graph has bars of unequal width, you must scale the height down using frequency density. Total area equals total frequency every time. Common mistake: plotting the raw frequency as the height when the class widths are unequal. You'll get a misleading picture with the wide bars looking way too tall. Always check the class widths first. If they're all equal, you can use frequency. If they differ, you must use frequency density. Quick example: class width 5, frequency 20, density is 4. Class width 10, frequency 20, density is 2. Both bars represent 20 data points, but the second bar is half the height. Because it's twice as wide, the area still equals 20. Hello and welcome to PH Maths. Today's explainer is scatter graphs and correlation. Correlation tells you whether 2 variables move together, but it does not prove causation. By the end of this video, you'll know how to read the trend and avoid the classic logical trap. Definition: a scatter graph plots paired data, 1 variable on each axis, 1 dot per data point. Positive correlation: both variables go up together. Negative correlation: one goes up while the other goes down. No correlation: the points form a cloud. No clear pattern. Key insight: draw the line of best fit so it splits the points roughly evenly above and below. Don't force it through the origin. It doesn't have to start at 0, 0. A strong correlation means the points cluster tightly around the line. Weak correlation means they scatter loosely. The tighter the cluster, the stronger the relationship. Critical warning: correlation is not causation. Ice cream sales and drowning rates may correlate, they go up together. But ice cream does not cause drowning, and drowning doesn't cause ice cream. Both are caused by hot weather. Always check for a hidden common cause before claiming one variable drives the other. Quick example: hours studied versus exam score. Positive correlation. Students who studied more tend to score higher. That doesn't prove study causes higher scores. Maybe motivated students both study more and score higher because of their motivation. But correlation is a strong indicator and worth working with. Just don't overclaim. Hello and welcome to PH Maths. Today's explainer is mutually exclusive events, two outcomes that can't both happen at once. By the end of this video, you'll know how to add their probabilities and the one situation where direct addition fails. Definition: two events are mutually exclusive if they can't both occur. So rolling a 3 and a 4 on a single die are mutually exclusive. You get one or the other, not both. When events are mutually exclusive, the probability of A or B happening is just the probability of A plus the probability of B. Direct addition. No overlap to worry about. Key insight: add probabilities directly when events are mutually exclusive. Roll one die, probability of 3 or 4. That's 1 over 6 plus 1 over 6 equals 2 over 6 equals 1/3. Simple addition. The events can't overlap, so nothing's double counted. Common mistake: adding probabilities of non-mutually exclusive events without subtracting the overlap. Draw a card from a deck. The probability of a king or a heart. Or some cards are both, the king of hearts. So you double counted if you just added. That's the overlap correction. Quick example: draw a card from a deck. The probability of king or queen. These are mutually exclusive. No card is both. There are 4 kings, 4 queens, and 52 in total. So add 4 over 52 plus 4 over 52 equals 8 over 52, which simplifies to 2/13. Hello and welcome to PH Maths. Today's explainer is independent events. Two events where one doesn't affect the other. By the end of this video, you'll know the multiplication rule and the trap of treating dependent events as independent. Definition: two events are independent if the outcome of one does not affect the probability of the other. For independent events, the probability of A and probability of B both happening equals the probability of A times the probability of B. Multiplication for and when events are independent. Key insight: two coin flips are independent. The second flip doesn't care what the first did, so the probability of heads then heads equals a half times a half equals a quarter. But drawing two cards without replacement is not independent, because once you've taken a card, the deck is smaller and the second probability has changed. Without replacement breaks the independence. Common mistake: treating without replacement draws as independent. Pick one card, don't put it back, pick another. The second probability has 51 cards in the denominator, not 52. And if the first card was a king, only 3 kings remain. Always check whether the second event depends on the first. Quick example: two fair coin flips. Probability of heads then heads. These are independent. So half times half equals a quarter. 3 coin flips, all heads, half cubed, equals 1 over 8. Same rule, applied repeatedly. Hello and welcome to PH Maths. Today's explainer is conditional probability, the chance of A happening given that B has already happened. By the end of this video, you'll know the formula, the new universe way to think about it, and the difference between conditional and joint probability. Definition. The probability of A given B is written the probability of A given B. The formula, probability of A given B equals the probability of A and B divided by the probability of B. The overlap on top, the condition on the bottom. The given is the new starting point. Everything is reweighted against B already having happened. Key insight. The given event becomes your new universe. You stop caring about what's outside it. Then within that new universe, work out the chance of A. So if you're told someone is a girl, your universe shrinks to just the girls. Within the girls, what fraction play hockey? That's your conditional probability. Common mistake. Confusing the probability of A given B with the probability of A and B. The first is conditional. Given B has happened, what's the chance of A? Whereas the second is joint, the joint chance of both A and B happening. Different concepts, different numbers. Read the wording carefully. Quick example, class of 30, 16 girls, and 10 of those girls play hockey. Probability of a hockey given girl, restrict to the girls. So within the 16 girls, 10 play hockey. So the conditional probability is 10 over 16, which simplifies to 5 over 8. Hello and welcome to PH Maths. Today's explainer is gradient, how steep a line is, rise over run. By the end of this video, you'll know the formula, the sign convention, and the trap of subtracting in inconsistent order. Definition. Gradient equals the change in y divided by the change in x, written as y2 minus y1 all over x2 minus x1. Pick any 2 points on the line, subtract the y values, subtract the x values, and divide. The answer is the same regardless of which 2 points you choose. That's what straight line means. Key insight. Positive gradient means the line goes up from left to right. Negative gradient means it goes down. The bigger the absolute value, the steeper the line. So a gradient of 2 is steeper than a gradient of 1/2. A gradient of 0 is a horizontal line. An undefined gradient is vertical. Common slip. Subtracting in inconsistent order. If your top is y2 minus y1, your bottom must be x2 minus x1, not x1 minus x2. Same order, both axes. Mix that up and you'll get the right magnitude with the wrong sign. So pick a top and a bottom point and stick to it. Quick example, line through 1, 3 and 4, 9. Gradient equals 9 minus 3 over 4 minus 1. So that's 6 over 3, which equals 2. Positive gradient, so the line goes up. Slope of 2. For every step right, the line rises by 2. Hello and welcome to PH Maths. Today's explainer is y equals mx plus c, the equation that captures every straight line. By the end of this video, you'll know what m and c mean, how to read them off any line equation, and the rearrangement trap that catches half of candidates. Definition. In the equation y equals mx plus c, the m is the gradient, the steepness of the line. The c is the y-intercept, the value of y when the line crosses the y-axis. So y equals 3x plus 5 has a gradient of 3 and a y-intercept of 5. Two numbers, full description of the line. Key insight. Rearrange any line equation into the y equals mx plus c form first. Then the m and c just jump out at you. So if you're given 2y minus 6x equals 4, divide by 2 and rearrange. Y equals 3x plus 2. Gradient 3, intercept 2. And remember, parallel lines have the same gradient, just different intercepts. Common mistake. 2y equals 4x plus 6 does not have the gradient 4. Divide both sides by 2 first. Y equals 2x plus 3. Now the gradient is 2. If the coefficient of y isn't 1, you have to divide everything through before reading off m and c. Quick example, y equals 3x minus 7. The gradient m is 3. The y-intercept c is minus 7. The line crosses the y-axis at minus 7. 2 pieces of information, both visible at a glance once the equation is in standard form. Hello and welcome to PH Maths. Today's explainer is the turning point of a quadratic, the bottom or top of a parabola. Every quadratic has exactly 1. By the end of this video, you'll know how to find it by completing the square with no calculus needed. Definition. The turning point is the minimum or maximum point of a quadratic y equals ax squared plus bx plus c. So if a is positive, the parabola opens upwards and the turning point is a minimum. If a is negative, the parabola opens downwards and the turning point is a maximum. 1 turning point per quadratic, always. Key insight: complete the square. Once you have the form y equals x plus p all squared plus q, the turning point sits at the coordinates minus p, q. The x-coordinate is the opposite of what's inside the bracket. The y-coordinate is the constant on the outside. Read them straight off. Common slip. The sign of the x-coordinate. X plus 3, all squared, has turning point at x equals minus 3, not plus 3. The bracket reaches its minimum when x plus 3 equals 0, which is at x equals minus 3. So always flip the sign. Quick example. Y equals x squared plus 6x plus 5. Complete the square. Equals x plus 3 all squared minus 9 plus 5. Equals x plus 3 all squared minus 4. Turning point at minus 3 minus 4. Minimum value is minus 4. Done. Hello and welcome to PH Maths. Today's explainer is the inverse function, the function that undoes the original. By the end of this video, you'll know the swap and solve method, the graph reflection rule, and the common confusion with reciprocals. Definition. The inverse of f, written f to the minus 1 of x, is the function such that f composed with f to the minus 1 equals x. Or in plain English, apply f, then apply the inverse, and you're back to where you started. The two functions cancel each other out. Method. Write the function as y equals f of x, and then swap x and y. Then solve for y. That new y is your inverse. So if f of x equals 3x plus 5, write y equals 3x plus 5. Then swap x equals 3y plus 5. Solve for y. So y equals x minus 5 all over 3, and that's the inverse. Critical warning, the inverse of f is not the same as 1 over f. F to the minus 1 of x is the inverse function. 1 over f of x is the reciprocal. So the inverse of f of x equals 2x is x over 2, not 1 over 2x. Different concepts entirely, so don't mix them up. Quick example, f of x equals 3x plus 5. Do the swap. X equals 3y plus 5. Solve it. Y equals x minus 5 all over 3. So the inverse is f to the minus 1 of x equals x minus 5 all over 3. Plug f, then f inverse, and you get x back. Confirmed. Hello and welcome to PH Maths. Today's explainer is graph transformations. F of x plus a, f of x plus a inside the bracket, f minus x, all those weird ones. The rule for horizontal shifts is the counterintuitive one. By the end of this video, you'll know it cold. Definition. Transformations applied outside the bracket affect the y-axis. These are vertical changes. F of x plus a moves the graph up by A. Transformations applied inside the bracket affect the x-axis, horizontal changes, but backwards. F of x plus A moves the graph left by A. Outside is intuitive, inside is reversed. Key insight: f of x plus 2 means shift up by 2. F of x plus 2 with the plus 2 inside the bracket means shift left by 2. Counterintuitive but true. The reason: to get the same output value, your input needs to be 2 smaller, so the whole graph slides left. Outside affects y, inside affects x, but backwards. Common mistake: the direction of the horizontal shifts. F of x plus 2 goes left, not right. F of x minus 2 goes right, not left. The sign inside the bracket is opposite to the direction of shift. Make a small table on your paper at the start of any transformations question. Saves marks every time. Hello and welcome to PH Maths. Today's explainer is the tangent to a curve, a straight line that touches the curve at exactly one point. By the end of this video, you'll know the gradient rule and the perpendicular to radius rule for circles. Definition: a tangent is a straight line that touches a curve at exactly one point without crossing it. At the point of contact, the gradient of the tangent equals the gradient of the curve. For a circle specifically, the tangent at any point is perpendicular to the radius drawn to that point. Key insight: for a curve, find the gradient of the curve at the point of contact, using differentiation at A-level or by inspection at GCSE. That's the gradient of your tangent line. And for a circle, the tangent gradient is the negative reciprocal of the radius gradient, because they're perpendicular. Common confusion: a tangent touches at exactly one point. It just kisses the curve. A chord cuts through the circle at 2 points. Don't mix the two. The tangent is the limiting case of a chord as the two crossing points merge into one. Quick example: circle radius 5 with a tangent at the point 3, 4. The radius gradient, the rise over run from the origin to 3, 4, equals 4 over 3. So the tangent gradient, which is the negative reciprocal, is minus 3 over 4. Perpendicular every time on any circle. Hello and welcome to PH Maths. Today's explainer is vectors, quantities with both magnitude and direction. Not just a number, but a number with a direction attached. By the end of this video, you'll know how to add them, scale them, and spot parallel vectors instantly. Definition: a vector has magnitude and direction. Written as a column, x is on top and y is on the bottom, or as an arrow in a diagram. The vector x, y means x units right and y units up. Vector a, b from point A to point B is the displacement from A to B. Direction matters. That's what makes a vector different from a number. Key insight: two vectors are parallel if one is a scalar multiple of the other. So A parallel to B means A equals K times B for some number K. If K is positive, they point the same way. If K is negative, opposite ways. To check parallelism, divide corresponding components. Same ratio means parallel. Common mistake: vector AB and vector BA are negatives of each other, not the same. AB means from A to B. BA means from B to A. That's the opposite direction. They have the same magnitude but opposite signs. So vector BA equals minus vector AB, always. Quick example: vector A equals 3, 2. 2A equals 6, 4. same direction, twice the magnitude. Minus a equals minus 3 minus 2, same magnitude, opposite direction. All three vectors are parallel, same direction line, different scaling. Hello and welcome to PH Maths. Today's explainer is iteration. Take a rough estimate, plug it in, get a better one, repeat. By the end of this video, you'll know how to apply an iterative formula, why it converges, and how to maintain accuracy. Definition. An iterative formula has the form x sub n plus 1 equals f of x sub n. Each new value is computed from the previous one. You start with an initial guess x sub 0, apply the formula to get x sub 1, apply again to get x sub 2. Each step refines the estimate. Key insight. If the sequence converges, meaning successive values get closer together, the limit solves the equation x equals f of x. So iteration is a way of solving equations that can't be solved by algebra. Round each x to at least 4 decimal places during the iteration. Round only at the very end to the asked precision. Common mistake, rounding too early. If you round x sub 1 to 1 decimal place and then plug that into the formula for x sub 2, you've baked the error into every subsequent step. Keep 4 decimal places or more throughout the working and round only on the final answer. Quick example, x sub n plus 1 equals root of x sub n plus 2. Well, start with x sub 0 equals 1. X sub 1 equals root 3, about 1.732. X sub 2 equals root of 3.732, about 1.932. X sub 3, about 1.983, converges to 2, which is the exact solution. Hello and welcome to PH Maths. Today's explainer is upper and lower bounds. A measurement isn't a single number, it's a range. And by the end of this video, you'll know how to find both bounds and how to combine them for the maximum or minimum of any expression. Definition. When a value is rounded to a certain place, the upper bound is half a unit above the rounded value. The lower bound is half a unit below. So 5.4 to 1 decimal place could really be anything from 5.35 up to, but not including, 5.45. The upper bound equals 5.45, the lower bound equals 5.35. Key insight. To maximize a plus b, use upper bounds for both. To maximize a minus b, use the upper bound for a and the lower bound for b, because you want the biggest thing on top and the smallest thing being subtracted. To maximize a divided by b, upper bound for a, lower bound for b, i.e. big top, small bottom. Same logic for minimum, all reversed. Common mistake is picking the wrong bound. To maximize a fraction, you don't want both upper bounds, you want a big numerator and a small denominator. Same for subtraction. Big first term, small second term. Think about what makes the expression as big as possible. Quick example, x equals 5.4 to 1 decimal place. The exact value of x lies in the range 5.35 less than or equal to x, and x less than 5.45. The upper bound is 5.45, strictly speaking an open boundary, but treat it as the maximum for the calculation, and the lower bound is 5.35. Hello and welcome to PH Maths. Today's explainer is composite functions. Fg of x means apply g first, then f. The g is closer to x, so g goes first. By the end of this, you'll know the right to left rule and why fg of x is not the same as gf of x. Definition. fg of x equals f of the quantity g of x. The output of g becomes the input of f. So you're applying two functions in sequence, g first, then f. The notation looks like multiplication, but it's actually composition. Two operations stacked. Key insight: read right to left. The function closest to x is the one you apply first. So in fg of x, g is right next to the x. G goes first. Then f acts on whatever g produced. Fg of x is not the same as gf of x. The order matters, exactly like the order matters when you do operations on a calculator. Common mistake: reading composite functions left to right. Resist that instinct. Composite functions go right to left. The inner function evaluates first, the outer function second. So double check the order before you start calculating. Quick example: f of x equals 2x plus 1. G of x equals x squared. So f g of x equals f of x squared, which equals 2x squared plus 1. Now if you reverse it, g f of x equals g of 2x plus 1, which equals 2x plus 1, all squared. Completely different result. Order matters.